Hello, my dear students. Welcome back to my YouTube channel. I hope I'm audible and visible to all of you. Hello, beta. Good evening. Good evening. Good evening. Am I audible and visible to all of you? Am I audible and visible? Okay. So, in the last two classes, we discussed about first law, second law, third law. What is momentum? M into V. What is inertia? What is rocket propulsion? All these things we discussed in the last two classes with lot of numericals. Hello beta, good evening beta. Good evening Ria. Good evening. Now from today onwards we will be studying about multiple forces just like weight, normal force, tension, spring and friction. Okay, from today onwards we will be starting forces, how to identify forces, what will be the nature of these forces, and how to deal with the numerical problems associated with those problems, with those concepts. Okay, shall we start now? I guess we are ready to go. Okay, so let us start. Okay, I guess my screen is visible to you now. Reba, hello beta. Okay, so I guess my screen is fully visible to you. Be more energetic, right? And pay full attention towards the class. Full attention. Okay, now in today's class, what we will be starting with, we will be starting forces in mechanics. So I can write here important forces in mechanics. Important forces in mechanics. Important forces in mechanics. So in mechanics, what we will be dealing with. First thing that we are discussing here, that will be a weight. That is weight. First force, that is weight. We need to study weight. Second force is normal reaction. Second force will be normal reaction. Third force will be tension. Tension. Fourth will be spring force. Fourth will be spring force. And fifth will be friction. Fifth will be friction. So it simply indicates that we need to study these 5 forces in whole mechanics. Whether we are dealing with NLM, circular motion, work, power, energy, okay, we will be dealing with these forces: weight, normal reaction, tension, spring force and friction. Done? Done beta? Okay, so before starting any of the force, one thing that you should be aware, that is free body diagram. That is free body diagram. Free body diagram. In a shortcut way, we can represent it with FBD. We can represent it with the FBD, free body diagram. Sir, what is free body diagram? Free body diagram simply indicates it is a diagram. Free body diagram is a diagram. Free body diagram is a diagram. First thing, it is a diagram. And this diagram shows all external forces, all external forces acting on body. Acting on body. So what is FBD? What is free body diagram? So free body diagram is a diagram that shows all the external forces acting on that particular body or an object. Just like we are having the surface, and on the surface we are having two bodies, one body and one more body. This body with mass and body with mass small m, and we are pushing the bigger one with force F, and this surface is smooth. This surface is smooth, that means no roughness, no friction. So I can take this body out now. So this is my body M. We know gravity will act downwards, so mg will act downwards. There will be one more force N. The force is pushing this body. One more force will be there, small f, right? So look, we are showing the forces, right? I know you don't know what is N1, what is this F. Okay, you don't know anything, but for a time being, I am showing the forces. So look, we created a body. On this body, we are showing all these external forces. Okay, so this particular diagram known as FBD. This particular diagram is known as FBD, free body diagram. If I will make a free body diagram of small one, it will looks like this now. It will looks like this. Done? It is free body diagram of small object, and this is bigger object. So we should be aware with what free body diagram is. Okay. Now free body diagram is a diagram which shows the effect of all the external forces acting on that object. Okay. Now let us start with very first thing, that is weight. So we now will start weight. We will now start weight. What weight is all about? What is weight? Weight simply means gravitational force. Weight simply means gravitational force. Weight means gravitational force with which Earth pulls the object. Earth pulls the object. So what is weight? Weight is gravitational force with which the Earth pulls the object towards its center. And weight is W, which is equals to mass of your object multiplied with G, acceleration due to gravity. Done? So if this is my Earth, this is a body. Okay. So if body's mass is m, so its weight will be towards the center of the Earth. This is mg. Done? What is weight? Weight is a gravitational force with which your Earth pulls the object towards its center. That is weight, which is equals to m multiplied with g. Nothing more complicated, very easy or extremely easy. Now, second force. Second force is a normal reaction. Second force is a normal reaction. Normal reaction. Normal reaction simply means, if let us suppose we are having bodies. Look, this is my table. This is my table. And on this table, I place it of mass m. Of mass m. What we observe that, let us think about this surface. This particular is a surface of your object, and this one is the surface of the table. Okay. Look now. Look now. What happens here now? What happens here? Due to the weight, due to the mass of your object, it gets downward force known as gravity. Okay. So look, this is my table. This is what? An object. Object is pressing it, no? This object is pressing the object, this object downwards. Look, this hand, when I am taking this hand on this one, no? So it gets pushed, no? Downwards. That means earth is pulling it, no? So it is just suppressing it, it is just compressing it, due to which it is surface, is acting a force on its surface that is perpendicular, due to which it is surface is pushing it now backwards. Let's go back. Why? Because it is surface is disturbing it, so the pushing it back, and this pushing back is known as normal force. This pushing back is known as normal force. Okay, clear now? So upper will push it downwards, it is normal one, and below one pushes it back, N1. So normal is always a pushing force. Normal is always in a form of push, and it acts in a pair. It acts in a pair. And one more thing, it is electromagnetic in nature. It is electromagnetic in nature. Electromagnetic in nature. Why, sir, it is electromagnetic in nature? Look now. If we zoom it, so we will find the layer of atoms of the upper mass. Okay, look. And now lower we are having a table. These are the atoms of table. Initially layers are very apart from each other. Now after some period of time, I am just placing it over. It will be this positive get lid. So this positive is repelling this one, and this repulsion is known as normal. And this is repelling this one, this is also known as normal. So this repulsion means normal. So this repulsion means normal. That's why the reaction of matter, if we are going deep into it now, we find that on atoms pushing in what? In pairs. Why? Because in Coulomb's law we know it, no? If first object is pushing this object by some force, third law of motion, every action there is an equal and opposite reaction. Both are on two different bodies. Both are on two different bodies. Done? Easy? Now here, if let us suppose this is my surface. Let us suppose this is my surface. Okay, on the surface we are having a body. M. Body's mass is one second, beta. I will check it out. No, it is good now, no? Red is good now, I guess. Yeah, I got it. Sometimes it's stuck. I don't know why, right? I don't have any idea about it. I have the good internet connectivity. I don't know why. Okay, look now. So how to find the normal now? First of all, look, we need to find the forces on this box. So write the FBD of this. How to write? Yeah, sometimes it lags, right? I don't know the reason. I have the good internet connectivity, the Ethernet. I don't know. Na? Look now. So we know one thing, the gravity will act it downwards. Gravity acts it downwards, and normal reaction will act upwards. So can I write now? N is equals to M into G. N equals to M multiplied by G. Every time these are opposite to each other. Every time. Normal reaction is opposite to mg every time. 90, 180 degrees. So you can write, look now. Why these are balanced? Because my object is neither goes up nor goes down. It neither goes up nor goes down. That means it is at equilibrium position. So F net is 0. So upper force and below force are equals to each other. That's why N equals to mg. That's why N equals to mg. One more question. If my surface is inclined now. If my surface is inclined now. I guess it is visible to you now. One second. I will change the color firstly. Look now. This is my body. Okay. Now on this one, we are having a here. I am having an object. Mass of object is m. And what we know that gravity acts downwards. This is my mg. So let's take two components of mg. Two components, right? If this angle is theta, this will be theta. So this component will be mg cos theta. And this component will be mg sin theta. And perpendicular to this one, we are having one more thing, that is normal. So in this case, I will write my normal is equals to mg cos theta. My normal is equals to mg cos theta. Done? My normal is equals to mg cos theta. Easy or super easy? Easy or super easy? It takes some time to get these things into your mind. It takes some time. We will be discussing these free body diagrams in NLM, in circular motion, in WPE, in COM, in collision, in a rotational motion. Every time we need to define these forces. So don't worry now, you will get enough practice of these things. Okay, look now. If we are having multiple surfaces, if we are having multiple surfaces, so if these are multiple surfaces, how to make them normal reaction? How to make them normal reaction? How to make them normal reaction? Look now. Okay, so these are my bodies. Okay, you need to tell me how many normal reactions we are having. So these are very easy things, right? Look, it is touching here, so 90 degree. This is my one normal reaction. Look, one more normal reaction. In the same way here, normal reaction. Here, normal reaction. Same thing, touching here, normal reaction. Touching here, normal reaction. So what these things represent, these are normal reactions. I can write N1, N2, N1, N2, N1, N2. So normal reaction simply depends where your body is getting touched with different body. Okay, look, it is getting touched here now only. So it is normal reaction perpendicular to your surface. Every time normal reaction is perpendicular to your surface. Got it? If you are done with this case, now let us show you a case then. Let us show you then your case. That is, look. So we will be defining two cases. So look here. This one is 10 kg. This block is also of 10 kg. I am applying some force on the surface, that is 20 Newton. That is 20 Newton. So I need to find normal reaction in both the cases. I have to find normal reaction in both the cases. In first case, so first of all, one force will be downward, that means mg. That will be mg. Mass is 10, g is 10. 10 is 100. So we are having 100 Newton downwards. So to counter this 100 Newton, we are having a normal, that is N1. Only these two forces present. So I can write here N1 is equals to 100 Newton. N1 is 100 Newton. In the second case, same way, 10 G is downwards, that means 100 Newton is downwards and normal is upwards. Now you can write now, how many forces are upward? Only one force N. How many downwards? 100 is downwards plus 20 is downwards. So I can write N came out to be 120 Newton. Easy, super easy. Easy, super easy. Easy now? Easy better? Okay. One more thing. Look now. This is my surface. On this surface, I am having an object. Super easy, yes. We are having an object. Okay. And we are pushing the object in such a way, this force is 50 Newton. This mass of the object is 10 kg. And we are pushing it back with one more 10 Newton. Done. Find acceleration of this block. Find the acceleration of this block. How to find acceleration? First of all, make FBD. Make FBD. This is my box of 10 kg. That means 10 kg. 100 Newton will be downwards and normal reaction will be upwards. Done. In this way, 10 Newton is rightwards and 50 Newton is also in rightwards. So can I write now N1 is equals to 100 Newton? First thing. Now, what is net force acting on it? Net force. Look, 50 is rightwards, 10 is rightwards. So I can write 50 plus 10 is 60 Newton. But force is M into A. Is it M into A equal to 60? Okay. Acceleration came out to be 60 divided by M. I can write acceleration equals to 60 by 10. So therefore, acceleration is equals to 6 meter per second square. Acceleration is 6 meter per second square. Look, we are going with basics. Then with the numericals going on, we will add up the difficulty level of your numericals. But first of all, we need to understand the basics of numericals. How we need to deal with the numericals, or how to find acceleration, or how to find forces, how to identify forces, why we are adding the forces, on what grounds we need to subtract the forces. Okay. One more numerical. One more numerical. This is my 10 kg block. Here we are applying 50 Newton force. This side we are applying 10 Newton force. Find acceleration and normal reaction force. Okay, how to find acceleration and normal reaction force? Look now, if it is 10 kg, so this will be 100 Newton. Why? Because M into G. So opposite to it, we are having normal reaction force. So normal reaction force came out to be 100 Newton. One force is right, one effect. What is net effect? Net effect is bigger, 50 minus 10, which came out to be 14 Newton. And F net is m into A by second law of motion, into 40. A came out to be 40 by 10. A is equal to meter per second square. It is 4 meter per second square. Okay. Now you can see these forces are horizontal. Let us take a force which will be between the two, right? If this is my surface, we are having a force. Done, beta, yes. And the weight is given as the mass is 10 kg. We are applying a force. This is my force. This one is 50 Newton. This angle is 30 degree. Okay. Find all these things, normal and acceleration. Look now, 50 to this angle, this side will be 50 cos 30 degree. I can write 50 cos 30 is under root 3 by 2, which came out to be 25 under root 3 Newton. Okay. This side will be 50 sin 30 degree. Sin 30 is 1 by 2. So I can write 50 multiplied by 1 by 2. This side will be equal to how much? 25 Newton. Look now. This will be m into g. M is 10, g is 10. It is 100 Newton. There will be a normal reaction force. Done, no? So I can write, look, the block is not going up and down, no? It is only going forward. So up and down forces are balanced. If your body is not going up or down, that means forces are balanced. So can I write now? Upper force equals to lower force. Upper is n plus 25. Lower is 100. I can write n is equals to 100 minus 25. So my n came out to be 75 Newton. So one more thing, that, look, what is my F net? In horizontal, sir, that is 25 under root 3. Done, no? F equals to m into A. It is 25 root 3. Acceleration is equals to 25 divided by mass is 10 root 3. So my acceleration came out to be 2.5 under root 3 meter per second square. Meter square. Done? Done, no? Okay. Now, one more numerical, and this numerical, I am sure that you can do it by yourself. Okay. One numerical that I will just do you as a homework. So you can write this numerical as your homework, okay? We are placing two forces. So this angle is 30 degree. This angle is 37 degree. Mass is 10 kg. This force is 20 Newton. This force, let's say, is 50 Newton. Find normal reaction force. Find acceleration. These two things you need to find out. These two things you need to find out. Okay? Done? Okay. Now, one more thing, that is, if we are having inclined plane, this is my inclined plane. On this inclined plane, if we are having object, If we are having an object, this is my object, okay? Mass of the object is m. Find acceleration and normal reaction force if the angle is theta. How to do it? Look, we know one thing, that first of all gravity will act on it, that is mg. Now we will be taking it as component forms. This is theta, this could be theta. Now this would be mg cos theta, and this would be mg sin theta. So look, normal reaction force will across perpendicular to my gravity. Look, there is no use of this one now. I can write my normal is equals to mg cos theta. It is force. Okay. Now force in horizontal is equals to which force? Mg sin theta. I can write it is mg sin theta. And what is force? Force is m into a equals to mg sin theta. You can see m and m cancel out, so acceleration came out to be g sin theta. Acceleration nothing but g sin theta. So normal is mg cos theta and acceleration is g sin theta. Done, beta? Done? Any doubt? Okay. Now let us do a numerical now. We are having a body. We are having a body. This is my body. Okay. On this body, we are having, it is an inclined plane. Now on this inclined plane, we are having a small body like this. This is my small body. It's my small body. Done? Now, if we release this body, if u is equal to 0, mass of body is m. Mass of body is m. Okay? So what you need to find out? So after some time, it will reach this bottom, no? After some time, your block will reach bottom. Done? If the distance between final, the initial is 40 meter. If this is 40 meter, what will be the time in his journey? What will be the time in this journey? Look, we are having an inclined plane. On the very upper side, we are releasing it. Releasing means velocity 0. Now I just place it like this now. There is no friction. My box with mass m will slide down. It will cover 40 meter in some time t. So we need to find out that particular time t. How we can do it? Look, first of all, we need to identify number of forces. So we know that mg will act downwards. We know that mg, right? Mg will act downwards. And one force is this one. It is mg cos theta. One force will be like this. This is mg sin theta. So what is my acceleration? Sir, acceleration is g sin theta. We know it, no? If my angle is, that is about 30 degree. A, what is g? G is 10. It is sin 30 degree. A came out to be 10. Sin 30 is 1 by 2. Acceleration came out to be 5. So I can write a 5 meter per second square. Acceleration is 5 meter per second square. So we know one thing now, the S equals to ut plus 1/2 of at square. I can use it. Why? Because my acceleration is constant, so I can use this equation. Initially it is 0. 0, sir. S is 40. So 40 equals to 1 by 2. Acceleration is 5. Then we are having t square. So look, I can write it is 80. 80 divided by 5 equals to t square. Done? T square. So 5 1 is 5, 5 1 is 5, it is 3. 5 6 13, it is 16. So T came out to be 4 seconds. So in 4 seconds, your objective will reach bottom. Okay, that's why we are telling you that all the mechanics chapters are interrelated. If you don't know the equations of motion, how you can do this equation, right? That's why we are telling you that you need to do these things by your own. Okay. Now a last numerical from this topic, then we will start apparent weight. A very good topic now. Great one. Suppose we are having same. We are having same a thing like this. Okay. Now, onto it, we are having a box. We are having a box. Like this, okay? And box mass is 10 kilogram. This is 10 kilogram. We are applying a force onto it. We are applying force. This one is my force, and force is 40 Newton. Force is 40 Newton. And this angle is 37 degree. Find acceleration. Find normal reaction force. Find acceleration and find normal reaction force. That's why, look, I am giving you the good numericals, okay? So in this numerical, you need to get your acceleration and normal reaction force. Okay. So first of all, I need to take the break off of the forces. How, sir? Look, we know one thing that mg will act downwards. This is my mg. Mg will act downwards. So I can write here mg. Mg. You can see that mg is acting downwards. So I will take it as component forms. Okay. I will take it as component forms. You can see now. So now, as I took the component form, if it is theta, so this could be 37 also, 37 degree. So now, here I can write, this is mg cos theta. I can write mg cos 37 degree. Done? Done, no? And this could be, this one would be mg sin 37. Mg sin 37. Okay, I can write sin 37. It is sin 37. Done? Now we are having a force. So I can do one thing. I can take this force. I can take this force, you know, I can take it here. Look, there is no issue of taking this force like this now. We know we can take a vector parallel to itself. It doesn't change its value. So it is 40 Newton here. It's also 40 Newton here. Done, beta? So this angle could be also 30, theta 37. If it is 40, so this angle would be 40 cos 37. Done? And also this would be 40 sin 37. So when we are dividing and when we are taking the component formula, there is no use of these things now. No use. This is my normal. So can I write now normal is equals to mg cos 37. Done? Plus 40 sin 37. N. What is m? M is 10. What is g? G is 10. What is 37? 37 is 4 by 5. Plus 40 sin 37 is 3 by 5. 5 1 is 5, 5 2 is 10, 4 2 is 8, n came out to be, it is 80, plus 5 1 is 5, 5 8 is 40, 8 is 21, it is 21. So 24. N came out to be 4, 104. So my normal came out to be what? 104 Newton. One is done. Now what is acceleration? What is acceleration? Look, what is mg sine 37? So m is how much? 10. G is 10. Sine 37 is 3 by 5. 5 1 is 5, 5 2 is 10, 3 2 is 6. It is 60 Newton. 60 Newton. This one, it is 40 cos 37. Cos 37 is 4 by 5. 5 1 is 5, 5 8 is 40. 8 4s are 32 Newton. So what is F net? F net is equals to 60 minus 32. 10 minus 2 is 8. 5 minus 3 is 2. It is 28 Newton. That is m into a. So acceleration came out to be 28 divided by 10, which is equals to 2.8 meter per second square. You can take a filter to this one now. Important one. Done, beta? Done? Which one? Easy, right? Complete? Any doubt about this numerical? Then you can let me know. If not, then we can just start a new topic, apparent weight. Done? Okay, done now. So let us start a new topic known as apparent weight. Known as apparent weight. What is apparent weight? Apparent weight is a reading of weighing machine. But you in this numerical, you are telling me that you can write A equals to G sine 37. You can write it now. You want to write G sine 37? But if you can note down the formula where we use G sine 37, there was no force upside, no? No force upside. Done? There were no force upside. Okay. So, but in this particular case, there is a force, no? Look, 32 Newton is upside. Below is 60 Newton. How you can apply simply G sine 37? It is not possible. We are having forces. You need to crush these forces into the component forms. Okay? Okay. Now, apparent weight means it is a reading of your weighing machine. A reading of weighing machine. And weighing machine reads the normal reaction force. Normal reaction force. That means apparent weight is nothing. It is a normal reaction force. Okay. So by this formula, you can understood that what is apparent weight? Apparent weight is nothing. It is a normal reaction force. Apparent weight is a normal reaction force. Done. And how we can express the apparent weight? First thing, in SI system, we can use at Newton. We can use Newton. Or one more thing, we can use into kilogram weight. Okay? Or kilo or gram weight. Or kilogram force. Or gram force. Kilogram weight is approximately 10 Newton. And what is gram weight? Do you know? 980 dyne. In the same way, ground force is 10 Newton or 9.8 Newton. Ground force is 980 dyne. Okay, easy or it's very easy. Okay, now first case, apparent weight first case, case number first. Case number first, lift is at rest. Lift is at rest or moving uniformly. That means my acceleration is 0. Why? If this is my lift, this is my lift. Here a person is standing. Then here is a weighing machine. See now, this lift is going, let us suppose, upward with velocity v. That means acceleration is 0. If the acceleration is 0, what you will observe, sir, there will be a normal reaction force upwards and there will be mg downwards. So can I write now n minus mg equals to mass into acceleration? Yes, sir. So n minus mg equals to mass, acceleration is 0. So my n minus mg came out to be 0. So my n is equals to mg. What is mg? Mg is actual weight. Mg is actual weight. That means my apparent weight is equals to actual weight. My apparent weight is equals to actual weight. In what case? In this particular case, when my lift is at rest or moving uniformly. Done? It should go upwards v or downwards v, no issue. In both the cases, my answer is same. Okay, now second case. Second case. Case number second. Second case is, we are having a lift. This is my lift. A person is there. A weighing machine is there. Lift is going upwards with acceleration a. I can write here, moving upwards with acceleration a. With acceleration a. Okay. Now write the equation. Write the equation. Look now. One thing, sir, mg will act downwards, no issue. Normal will act upwards, no issue. So I can write now n minus mg is equals to mass into acceleration. So n is equals to mg plus ma. So n is equals to mg plus a. mg plus a. What is actual weight? Sir, my actual weight of this person is mg and my apparent weight, it comes out to be mg plus a. So it simply gives you idea that when a person is sitting inside the lift and lift is going upwards with the acceleration a, its weight increases. Its weight increases. Done, beta? Its weight increases. You need to understand this particular thing, that when a person is sitting inside the lift and the lift is going upwards with acceleration a, its weight increases. We are having a sub case of this one. Sub case means the case is under this case only. If lift is going upwards now, but it is going with retardation. It is going with retardation a. It is going with now retardation a. Then what will happen now? 1 second. Okay. Now, if it is going with retardation a, then what will happen now? Make equation is no issue. So look, retardation simply means this is my lift. Okay, mg will act downwards, normal will act upwards. Retardation is minus a. So write equation. I can write n dash minus mg equals to m minus a. Okay, I can write that n dash. Okay, this is n dash. N dash is equals to minus ma plus mg. So I can write equals to mg minus ma or mg minus a. So you can see that it is apparent weight decreases. It is 1 second, beta. सर मेरा कल पेपर है, कल सर वर्क पावर एनर्जी नहीं पढ़ा है. So in वर्क पावर एनर्जी do what you will do from that thing. So do one thing ना, अगर नहीं पढ़ा छोड़ दो उसको. Because work power energy is a basics of a lot of things, right? So how to find out work done in processes, what is spring cases. If let's say we drop something, a spring gas is compressor, so what should be, it is compressional thing, maximum compressional thing. Okay, जल्दबाजी में कुछ ना करें आप. अगर नहीं पढ़ा है, you can leave those topics. Okay, next time you can improvise yourself. There is no bad thing about it, no. If you don't know any part, don't worry, give your paper, come back, take your things, and just go on and clear those things that you have not done this paper, and you can do better in the second one. Okay. Okay. So if lift is not moving or moving with constant velocity, actual weight is equal to apparent weight. If lift is going up with acceleration a, it is apparent weight will be more than it is actual weight. Apparent weight will be mg plus a. Apparent weight. If lift is going upwards with retardation minus retardation a, retard means opposite to acceleration a. So my apparent weight will be less than the actual weight. That means mg minus a. Don't worry now. If you have any issues with work power energy, after NLM, we will start circular motion, then work power energy from the basics. Don't worry about anything, right? I am starting here now. These things from the very basics. Don't worry, right? I will just complete your whole syllabus. Don't worry, right? Within 3 months, I am going to complete your whole syllabus. To boards, to main, to NEET, to your JEE. Okay? But don't be in a rush. Okay. Now case number second is done. Case number third. Case number third. Okay, what is case number third now? Case number third. We are having a lift. Okay, here is a person. My weighing machine, lift is going downwards with acceleration A. So I can make the forces. My mg will act downwards, normal will act upwards. So I can write lift here. Lift is moving downwards with acceleration A. With acceleration A. Then how to write the equation now? Done now. Look now. First of all, my acceleration is less than acceleration due to gravity. So can I write now here my mg minus n is equals to, if it is m, right? M into a. Yes, sir. So I can write n is equals to mg minus ma. So n is equals to m g minus a. This one is my apparent weight. This one is my apparent weight. Apparent weight. It simply indicates if my lift is going downwards with the acceleration a, it is apparent weight is less than its actual weight. Now subcase, if lift is going downwards with retardation a, so I can write now mg minus n equals to m minus a. I can write mg plus ma equals to n. So my n came out to be mg plus a. So if my lift is going downwards with some retardation a, so my apparent weight increases. B subcase, if my a is equals to g, so my normal reaction force is equals to m g minus g. So my normal reaction came out to be 0. My normal is 0, and this condition is known as free fall. This condition is known as free fall. So I guess we are done with lift cases or apparent cases. Done, beta? Easy or super easy? Easy or super easy? Easy or super easy? Huh? Give me response now. Easy or super easy? Okay, I guess you are very busy with studies, right? Don't worry about anything, right? So let us start a numerical. And numerical is like a person of mass 50 kg is in a moving lift. Find out the apparent weight. Find out the apparent weight of the man. Apparent weight of the man. If lift is moving with, first case, an acceleration of 2 meter per second square in upward direction. B part, an acceleration of 2 meter per second square in downward direction. Okay, how to do these numericals? Look now, it is going in upwards. So in upwards we know that n equals to mg plus a case. N mass is 50 kilogram, g is 10, it is 12, 2, right? So n came out to be 50 into 12, it is 600 Newton. And what will be the reading of your weighing machine? Reading will be 60 divided by 10, that is 60 kilogram weight. B part, downward direction. So n is equals to m g minus a. M is 50, g is 10 minus a is 2, that means 8. So n came out to be 50 multiplied by 8, that is 400 Newton. It is 400 Newton. So a reading of your weighing machine will be equals to 40 kilogram weight. It will be 40 kilogram weight. Done? Done, no? Easy or super easy? Easy or super easy? Done? Easy, right? Okay. So write topic name as motion of bodies, motion of bodies in contact. Motion of bodies in contact. Motion of bodies in contact. Don't consider friction. Friction is not present. Friction is not present. My topic known as motion of bodies in contact. Done now. Look, if we are having two bodies, this body mass m, this body is one more mass m. We are pushing this body with force F. What will happen now? This body will go like this with some acceleration A. Take this body and make FBD. There will be a force. There will be a one more contact force, normal reaction. Mg will act downwards. It is weight, and normal reaction will upwards. So I can write now F minus F. F minus F equals to mass into acceleration, equation number first. Take second body, mass M, contact force, Mg, normal reaction force. Done? I can write F minus 0, because here no force is there, equals to M into A. So F came out to be M into A. Second equation. So now add these two. I can write F minus M into A equals to MA. So F is equals to MA plus MA. So acceleration is equals to F divided by mass plus mass, F net. If you want to find the net force, net acceleration will be F net divided by M plus M. And if you want to find this normal reaction, so normal reaction is M into A. F is M, look, M is M, what is A? A is F divided by M plus M. M plus M. But you don't need to write each and everything now. So I am going to give you a shortcut for this. I will be giving you the shortcut. Shortcut is net force divided by total mass is equals to acceleration. Shortcut. Net force divided by total mass will give you acceleration. Done? Okay. If you are done with these things, let you give you a numerical based on this particular thing. Let us discuss a numerical on it. Okay. We are having time now. We will discuss. If we are having something like this, no? Look. Then on top of it, we are having blocks. One block, one more block, and one more block. Three blocks. Mass is M1, M2, mass is M3. we are applying force F. Due to this force, acceleration will be there. Okay, first of all, we will give a lengthy process. Look, I know acceleration is net. What is net force? Force is only F. What is net mass? It is m1 plus m2 plus m3. This one is from shortcut. So I will show you a force, a way of doing this force, right? Look now, for this box, I will write equation. F will be there. From this side, F1 is there, M1 is there. So can I write now F minus F1 equals to mass into acceleration? First equation. For second box, M2, there will be a one more contact force F2. From this side, one more contact force F1. So I can write here F1 minus F2 equals to M2A, second one. Now third one is M3. We are pushing it by F2. So I can write F2 minus 0 equals to M3 into A, third equation. Done? Add all these three equations. We will find F minus F1 plus F1 minus F2 plus F2 equals to M1A plus M2A plus M3A. Look, F2 cancel, F1 cancel. So my F came out to be, I will take A common. So internal we are having M1 plus M2 plus M3. So my acceleration came out to be F divided by M1 plus M2 plus M3. Okay, you can see my shortcut and my this process is same. Now if you want to find these normal forces, the contact forces, how you will find? I will firstly find F2. So F2 is equals to M3 into A. A is F divided by M1 plus M2 plus M3. What is F1 now? F1, right? F1. So I can write F1 is equals to F2 plus M2A. So F1 is equals to F2. What is F2? F2 is equals to M3. Then we are having F divided by M1 plus M2 plus M3 plus M2 times A. What is A? A is F divided by M1 plus M2 plus M3. So my F1 came out to be, it is M2 plus M3. Here is F divided by M1 plus M2 plus M3. This is how you will do these things. Easy or super easy? Easy or super easy? Amida? Easy? Okay, so let us start a numerical. Huh? I guess we have not discussed very things, right? Okay. Now we are having two bodies. One body, one more body. Okay. 2 kg, 3 kg. Pushing with a force of 30 Newton. Pushing with a force of 30 Newton. Due to the 30 Newton, there will be acceleration like this. Okay. Let us do a shortcut now. Don't worry about the equations now. What is F? It is 30 divided by, it is 2 plus 3. 30 divided by 5. 5 1 is 5. 5 6. So my answer is 6 meter per second square. What is F now? F, right? So F will be 3 kg. It is 3 into A. 3 into 6. 18 Newton. Okay. Look, in the previous numerical, it takes almost 5 minutes to derive these things now. But once we get these equations, now we are very good now to write the shortcut now. Why we need to write each and everything? If we now know the basics of doing numerical, if we now know the result of it, then why doing from the basics now? Okay, one more thing. This block is 2 kg, this block 3 kg, 5 kg. Look, there will be F1, F1, F2, F2. We are pushing it with the 60 Newton. Done? So how to write A? A is net force is 60 divided by net weight. It is 2 plus 3 plus 5. 2 divided by 10. It will be 6 meter per second square. If you want to find F1, find F1. So F1 will be weight of this one and this one. So it will be 3 plus 5 into acceleration A. It is 8 divided by 8 into 6. Right? That is 48. If you want F2, F2, how many particles are there? Only one. So I can write 5. 5 into 6. It is 30 Newton. As simple as it is. We don't need a long methods to do these things. Okay? Look now, you can see now I am increasing the pace of teaching. I am increasing the way of defining things. Why? Because I know you that you are with me from last 2 classes. So you have got the style of my teaching, right? How I am taking these things. First of all, what I am doing now. Then second, third, fourth numerical, we are doing a shortcut manner. Why to waste the time in doing all these some equational things, right? If we know the shortcut, do the shortcut now. Okay, let us do a different numerical now. Look now, beta. 20 kg, 10 kg. This force is 120 Newton. This force is 300 Newton. Find acceleration. We know the acceleration is net force divided by mass total. What net force? Look, we're having 300 minus 120 divided by 30. It will be 0, 0. 10 minus 2, it is 8. 2 minus 1 is 1. 1 divided by 30. Cancel out, it is 18 by 3. That is 6. So my acceleration came out to be 6 meters per second square. Now, if you want to find the normal force, there will be a normal force, no? F1, F1. So F1, I can write it equals to, look, 10 into 6. I can write 10 into 6. Done. And plus 120. Plus 120. Done. Do you know why? If you don't know the reason, now look now. Look, F1 is in this way, so I can write F1 minus 120 is in this way, I can write 120 equals to M into A. 10, it is 10 into 6. So F1 equals to 60 plus 120, that means 180 Newton. 180 Newton. Okay, now one last numerical. One like this, one like this. 20 kg, 10 kg, 200 Newton, 50 Newton. Find acceleration and normal reaction force. That means F. Find. I am giving you a time now. Find. Okay? Which one better? Ria, which one? Which one better? Okay. Look now. This one now. Look. We are having a box like this. F1 is acting like this. 120 is acting like that. Mass is 10 kg. Acceleration is 6 meter per second square. What will be the value of F1? Okay. Look, F1 is acting rightwards, so I can write F1 minus 120 backwards, right? Opposite minus 120 equals to mass into acceleration. F1 minus 120. Mass is 10, acceleration is 6. So F1 minus 120 came out to be 60. So F1 is equals to 60 plus 120. So F1 is equals to 180 Newton. Easy? Okay. This one now. Look, if we observe these two forces will take the boxes apart from each other. That means we are having boxes separately now. Separately. So this box is going with 200 Newton with mass 20 kilogram. This box is going with 50 Newton, mass 10 kilogram. So acceleration will be different. It will be 200 divided by 20. That means 10 meters per second square for this one. And A2 will be 50 divided by 10. A2 will be 5 meter per second square. If we talk about the forces, normally 0. The reason is my two sides of the block is now apart from each other. There is no contact between the two forces, sorry, two bodies. There is no contact between now these two bodies. If there is no contact, so no normal reaction force. So A1 is having different force, A2 is having different forces. Okay, normal is 0. Easy, beta? Okay, so we are done with today. Tomorrow we will do tension. Tomorrow topic will be tension plus pulley. Tomorrow we will try to complete tension plus pulley. Okay? Any issue with today's class? Is there any issue with today's class? Huh? Easy now? Okay. So I guess we are done with today's session. Tomorrow we will be having tension pulley. Then day after tomorrow we will be having uh, spring force. Okay. Then apart spring force we are having pseudo forces. Then friction. It will take more 1 day, 2, 3 to 4 days. If we will go with this particular pace, next to 3-4 days we are done with NLM. Basically NLM takes usually it will take around 16 or 18 lectures in a normal pace. Okay, NLM takes, I am taking 16 to 18 lectures to complete NLM, but here on YouTube, right, we don't have that much of interaction like the offline classes. So that's why here we can take up to 6 to 8 classes. Okay, so within 6 to 8 classes we will complete NLM. Then we are having circular motion. It will take more 3 to 4 days. Then we are having WPE, more 3 to 4 days. In this way we will complete the whole syllabus. Okay, for today We discussed more than enough. If you're having any trouble or if you're having any issue, you can let me know. Okay, we will discuss these things. If you want anything, na, you can do one thing. You can join my Telegram group. Na? There you will get regular updates and you will get notes of these classes as well. If you are not getting time to note down each and everything, you can join my Telegram group. There you will get these things. Okay, and you know that morning session is for Hindi classes. We are doing 12 there. So if you are weak in 12th also, you can join those sessions also, right? Ria is coming to those sessions and a couple of more students. If you want, you can join these sessions also. And for today, thank you very much and good night. Take care. Bye, beta. Bye.